Page 58. Read the question and tell your partner, how many stable isotopes does gallium have? Page 58. It has two stable isotopes. Okay? One is gallium-69. So I'm actually going to summarize this information down below because sometimes it's hard to pick it out. So we have, here is gallium-69, and it is 60.11% abundant. Do you know what that means when it says 60.11% abundant? How many people feel like they might know what that means? I got 1, 2, 3. Okay, for the rest of you who don't know what that means, what it means is that out of all the atoms in the universe, out of all the atoms of gallium, 60.11% have a mass of 69. Okay? Now we have another isotope. Our second isotope is gallium-71. Okay? And it is 39.89% abundant. Now, what do you get if you add 60.11 plus 39.89? You should get, tell your partner, what should you get if you add 60.11%, which is gallium-69, and then we have gallium-71, which is 39.89%. We should get 100, yes? Because if you only have two isotopes and one is at 1%, the other has to be 100 minus that percentage. Okay. So let us write down a couple of things here. We have gallium-69, which is at 60.11%, and we are told, now this language here is a little tricky. Do you see how it says the masses of gallium-69 and gallium-71 are blah-de-blah and blah-de-blah respectively? Do you guys know what that word respectively means? No. Okay. What it means is that the first mass goes with the first isotope listed. Whenever something says respectively, it means the first thing goes with the first thing and the second thing goes with the second thing. Okay, that's what respectively means. First thing goes with the first thing, and the second thing goes with the second thing. It's useful to know that because questions often come up that have that word respectively in them, and if you don't know how to read that, it can be very confusing. So knowing that, what is the mass of gallium-69? It is 68.926 AMU because that's the first one goes with the first mass. So we're going to write that down here. We have 68.926 AMU. Now, the second one that I've highlighted in blue, the gallium-71, okay, the gallium-71 has a mass of 70.925 AMU because that's the second one and it goes with the second mass. So we can write down our information about gallium-71, Ga71, and that is 39.89% abundant. That means 39.89% of all the atoms in the universe of gallium have a mass of 71, or more specifically, 70.925 AMU. Now, if you're like me, you're probably saying, I look at 69 and then I look at 68.926 and I say, those are not the same number. Those are slightly different. Yes? And I look at 71 and I look at 70.925 and I say, oh, that is also slightly different. I believe that the reason is that when protons and neutrons combine in the nucleus, some mass is changed into energy. Cool. How does that happen? Energy is equal to mass times the speed of light squared. And when you have nuclear reactions, you can actually have mass lost or mass gained when a nuclear reaction takes place. Chemical reactions, you will never have a loss of mass. You will never have a gain of mass. Your mass before will always be the same as the mass after. But if you start smushing nuclei together, there's so much energy involved in that some of it gets changed into mass or vice versa. To be truth be told, I don't understand this part. You don't need to know this part. You can be like, okay, thank you, Einstein. Thank you for your theory of general relativity. And you can ignore that. And you can just say that I am going to believe the question when the question tells me that instead of using the number 69, I'm going to use the number 68.926. Yes? And instead of using the number 71, I'm going to use the number 70.925. Is good? Okay, so let's do this question. Now, what we do is we take the percent abundance A times mass of isotope A. And then we add it to the percent abundance of isotope B times the mass of isotope B. And it doesn't matter which isotope you assign the letter A and the letter B, okay? Let's just call this one here A, and let's call this one B, okay? And this is going to equal our average atomic mass. So far, so good? Okay. So in this case, now when we do the percentage, it has to be a decimal percent. Do you know what I mean by a decimal percent? It means instead of writing 75%, you would write 0.75. Okay? So a decimal percent, 75% would become 0.75. Yes? 20% would become 0.2. You guys are familiar with doing that in math? Okay. So we're going to take our 60.11%. What would we write that as if we're writing it as a decimal percent? 0. If we're taking our 60.11, it would become 0.00. 6011. Okay, so that is our percent abundance. And now we need to multiply by the mass of A. Okay, and the mass of A is 68.926. Do I need a unit with that number? AMU. Okay, AMU. And then we're going to add to that our percent abundance of gallium-71, which is 39.89%. So instead of writing 39.89, what do I write? 0.3989. And then we're going to multiply that by 70.925. Oh, do I have my calculator here? I do. Yay. Okay, and just because I want to make sure that my sig figs are good, I'm actually going to do these two calculations separately. Yes. Sorry? Ooh, I forgot the AMU. Yes, thank you. AMU. AMU. There we go. Unit. So 0.6011 times 68.926 equals 41.4314. And then I'm not going to write all the digits. I'm just going to go up to 41.4314. How many sig figs would be in this number if this were the end of my calculation? There would be 4 sig figs. So I'm going to say, even though I'm writing out 2 extra digits, I'm going to say this number has 4 sig figs. I'm going to keep 2 extra digits to prevent a rounding error. And is there a unit with that number? Still AMU. Okay, still AMU. Okay. And now our next calculation, we have 0.3989 times 70.925 equals 28.29198. 29198. All right, how many sig figs would be in that number? 4. Yes, because I've got 4 sig figs here, and I've got 4 sig figs here. It was just too much trouble to do the rounding because it ends up rounding to 28.2920, but that just seemed like a lot of work. So I'm just going to add these two together now. So 28.291 blah blah plus 41.4314 equals, and we get 69.7233. This is an addition. When we do addition, what did I forget? Oh, the AMU. Thank you. Who is our uncertain digit in 41.4314? 0.14. It's that 3. It's that second decimal place. Who is the uncertain digit in 28.29? The 9. Okay, so there is our uncertain digit there. So our uncertain digit is in the 2 position. And so our final answer will be 69.72 AMU. Fairly straightforward? Okay, excellent. Did you want to try? Oh, actually, no. The next one is just like it's a thinking problem. There's not actually a calculation to do. I'm going to read it to you, and you're going to think about it and discuss with your partner. Rubidium has 2 isotopes. We have rubidium 85 and rubidium. Oh, have I not fixed this thing yet? I swear to God. This should be rubidium 87. Okay, I need to fix this. The atomic mass of rubidium reported on the periodic table is 85.47. Based on this information, which of the isotopes of rubidium is more abundant? Do you know what it means when we say more abundant? It means which one is there more of? And we're looking for either rubidium 85 or rubidium 87. So chat with your partner. Which of those 2 is the most abundant, and how do you know? I don't hear much discussing. Tell your partner what you think. See if you agree. See if you guys have the same opinion. What do you guys think? 85 or 87? 85 or 87? Let's have a vote on that. And also, I don't know is a perfectly good option. Okay, I'm seeing some 5s. Those of you who think it's 5, why do you think it's 5? 85. Yeah, if we look at our number line here, we have 85. We have 87, and here's 86. Where is 85.47? $85.47 is closer to 85, so there must be more of that isotope in order for the average to be closer to that. Now, if anyone is finding this a little bit too easy and would like to learn how you could actually, for this question, find the percent abundance of 2 different isotopes from a question like this, I've printed off 5 of these because I think most of you probably just need the second example. But if you're bored and you're like, I could use a little something extra, this is enriched stuff here, if anyone is interested in that. Okay? Now, before you do that, do you want it?
Yeah.
Because you're finding this boring and you know how to do it and you're good?
No, I just want extra practice.
No. This is not extra practice. This is something different.
Oh, different.
This is different and harder, and you get to learn it on your own. But Lauren, would you like it? Yeah, why not? Okay. For those of you who are not taking that, what you're going to do, magnesium. Oh my goodness, now we have 3 stable isotopes. Could you guys do this one on your own? Hi.
I can just do the like what like what do you want to do?
Okay. Yeah. Yeah. So 2, 1, 7 times 10 to the minus 4 minus 4.26. 66 times 10 to the minus 5. Now we're changing this one times 10 to the minus 5, yes? Okay, and so that got smaller, so this is going to be bigger, so that's 12.17. Times 10 to the minus 5 minus 4.626 times 10 to the minus 5. Now we're going to factor out the times 10 to the minus 5, so we're going to have 12.17 minus 4.626 times 10 to the minus 5. And we get 12.17 minus 4.626 equals 7.544. Our uncertain digit is in the hundredths position and in the thousandths position. So I have an uncertain digit there. Yes. And an uncertain digit there. Yes. 2 decimal places, 3 decimal places. So I have to round it here. Yes. Yeah.
Oh, okay.
Yeah.
Yeah. Thank you. We're going to
Yeah. Are you guys actually trying this, or are you just goofing off? Because I can work through it with you, but I think you could do it on your own. You know what? Nobody's paying attention. I'm going to do it. If you're working on it on your own, see if you can beat me to the end. Okay? So we are calculating the average atomic mass. And we have 78.99%, so 0.7899 times 23.985 AMU. So that's our first. That's magnesium 24. Our second one, 10%. So 0.1000, it becomes 10%, times 24.986. And then 11.01%, so 0.1101 times, oh, and I forgot my AMU. Keep forgetting that. 25.983 AMU. Now I know that this number is going to have 4 sig figs, so I'm going to write down 6 digits. I like to keep 2 extra digits. So 18.9457. And I'm just going to mark down for myself that I have 4 sig figs. Now, all of us who are distracted right now, are you going to get 100% on this quiz when it comes around?
Yes.
Okay, excellent. This one has actually, I don't even need a calculator to do this. This is 0.024986. Oops, AMU. And finally, we have 0.1101 times 25.983 equals 2.8607. And again, we have 4 sig figs, 1, 2, 3, 4. 4 sig figs, 1, 2, 3, 4. 4 sig figs. So let's try it. 18.9457 plus 0.024986 plus 2.8607 equals 21.831386. Now comes the tricky part. That can't possibly be correct. It should be 24 or something. Hang on. What have I done wrong? Let me try it again. 0.7899 times 23.985 equals, okay, that one's correct. Oh, this should be 2 point. Oh, silly me. This should be 2.4986 AMU. That's better. And this would have 4 sig figs. Okay. 18.9457 plus 2.4986 plus 2.8607 equals 24.305. This is addition. Do I want to go to 2 decimal places or do I want to go to 3 decimal places? 2 decimal places because that's my first one. So there we go. So that would become 24.31 AMU. And what you guys are going to do for homework is page 66. Numbers 1 through 4. Actually, you know what? Pages 66 to 67, odd numbers. Odd numbers? Do I want it odd numbers? Pages 66 to 67, numbers. Numbers 1 through 5. There you go.
Yes.
Thank you so much.
No, I'll check it.
Yeah, for sure. Here, let's actually, hold on. Let's staple it all together for you. Yeah. There you go. Uh-huh. 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 Okay. You got it wrong. In what sense? What did you get? Yeah, but what did you get? Well, I don't, okay, then you should have gotten something very close to what we got.
It was.
Okay. Well, yeah, so let's just go plus 0.1 times 24, whoops. Plus, times 24, 6, plus 0.1101 times 25.83 close bracket equals. That seems odd. It shouldn't be off by that much.
I'm like asking some
Okay.
knowledge about the spectral theory.
Okay.
It's number 27,
Yep.
and I don't know why I got it wrong. I think it's really because I thought the solution is red because red is the only wavelength that it does not absorb, so therefore it's reflected. So if we dilute the red solution, then the amount reflected will decrease. So
Okay.
I thought that was that, but then it was diluted. I don't know what's the highlighted term.
Okay, electronic transmission. So an electronic transmission is when an electron is in an orbital, when it's in its ground state, okay? It can get bumped up if you fire light at it. So that's what's happening in the spectrophotometer. It gets bumped up
Yeah.
and then it can fall back down.
Hold on. Yeah.
Okay, that's what transmit. When the electron falls back down, you'll end up, yeah, I'm not sure, this electronic transmissions, this is not an awesome question, I'm not loving it,
Okay.
okay?
It's one thing for next week.
If the solution is diluted, the amount of light reflected will decrease. The amount of light absorbed will decrease. Because you're measuring it at a wavelength where the light is being absorbed.
Yeah.
Yeah, so I think that's what's wrong with the light absorbed is decreased, yeah. Okay? And so basically what's happening is that the reason it's colored is because you get those popping up and down. Certain electron gaps, so it will be like that, yeah.
So like when you're on the side, it falls back.
It falls back down and it lets out some light, so that will be the red light. Yeah,
Thank
yeah.
you.
You're welcome. Hi.
I was just gonna ask, is it like possible, is there a possibility that can make up for like half a mark on my unit to test?
Let's take a look. In. May I ask why?
I kind of want to be like, I mean, if I can like make something, do something,
Uh-huh.
get like just like half a mark or a mark more.
Uh-huh.
Like I don't know. I was just wondering if there's a
Okay,
possibility.
well, hang on a second. Oh, you're wanting to get an A. Is that what's going on? You're like, yes. Well, you have another test,
Okay.
right? That other test is not your only test. There's also this test. How did you do on your other test?
Oh, the phone?
Yeah.
Oh, I think I got like 890.
Oh, and then that'll average to an A. So we have. So we have 30.5 divided by 30 equals. Yeah. Oh, that's your overall test mark.
Okay.
Yeah, when you have both of them together.
Okay.
Okay. Yeah.
And
So don't worry about an individual.
one more
test.
thing.
Yeah.
Is this quiz worth more than this?
No, quizzes are
Oh
only
yeah,
worth 10%.
they're in a different category. Right?
Different box.
Okay,
Yeah,
okay.
yeah.
Thank you.
No problem. I'm okay. How are you? Good. Yeah. I
Yeah, you think there's a question.
I just want to not be too complicated. Because like I keep my brain smart.
Usually it just goes on the end, if there's an end. If not.
Oh yeah. Okay. I know one smart.
Okay. Yeah, don't worry about that. We're gonna get to these ones and I'll go you actually on your booklet, so you don't have to. Yeah.
Okay, bye.
Okay. Okay, extract the dot. Sorry, what? You're gonna go. You're fine. No, I wanted everyone to study over the break, but we're not even finished that part, that section. I'd rather finish that section than have a proper quiz on it. Yeah. Okay, dot cab. How do I extract the dot cab file? Okay. Where is it? Downloads. Downloads. Hi.
You need to be worried about this quiz.
No,
As long as I've looked over all this.
you'll be fine.
I can do it.
Don't sweat. Enjoy your lunch. Yes. Huh? Why? Oh, okay. How do I extract you? Extract. Yes? Extract all. How come I can't extract you? Oh.
First off, having that.
Hi, everyone. So I've downloaded the file
Okay,
and it says to extract it.
yeah.
Because I'm reading in the instructions from somewhere, but I don't know how to extract it. So if I show in folder, here it is.
It's a cabinet file.
Yeah. And so I looked here because this one gave me instructions. It says go to extract the .cab file to a folder of your choice.
Oh, I see. But then we don't
And
know
I don't know how
what
to
folder we need to put it in.
extract. Well, it just says a folder of your choice.
So I guess any folder?
Yeah, but I don't know how to extract it. That's my problem.
Where is the folder? Is it here? Download?
Yeah.
Yeah.
I'll remember today.
Went to England. It was sunny. Can't complain.
I did.
And you don't have internet to download the files to download the
With the last 5 days, nice here.
Stuff done that I needed to do.
Open the file or double click the file.
The last 5 days were, well, I was assuming that Seattle was kind of similar to here. It was like sunny.
Right click and then it says click extract. But where?
There's no extract. I know.
I guess we're just gonna be on our own respectively.
Yeah, just east of Seattle on that like peninsula, kind of Port Townsend. Like kind of, yeah.
Take a lunch.
It was so
Whole
great.
food burn.
Okay, so we need to download
We went to Seattle for the day and then
to extract the
To
file.
extract the cabinet file. So I'll need to go back to my room to do that. Okay, I'm gonna go do that.
7-zip.
Okay.
I figured you did.
What's the
7-zip.
7-zip?
7-zip.
Okay.
Yeah.
Big afternoon.
We didn't. Like,
Hi. I'm having so much fun because Alan is here, but this won't do anything with the internet because I need to plug it in because I need to get the driver from the internet so that it'll be able to like fuck me. So I'm fuck me. Hi.
How's it been?
Oh, good until today.
Honestly, fair enough. Let me just not make this too bad. What the fuck is gonna be on the quiz? Because
Nothing. Don't worry about it. Go have a good lunch. Let me get my thing here done. Yeah. No, seriously, have a good lunch. Don't worry about it. Seriously.
Okay.
That makes me worry.
No, seriously, do not worry about it. Got it?
If we did all the homework, we'll be fine. Okay.
But
I need that.
I wasn't getting them.
I did most of it. I haven't done it yet. We'll probably do it.
that's like the only homework that's there.
It's so boring. I'm like, copy. And
Oh my god. Sure. Okay. Okay.
I don't know what I walked. Yeah. Who laughs? You?
It's not looking bad.
No, that's the one. Yes. Okay.
I get off on the road. Why would I? What would we?
Device manager. Device manager.
But you know, 6 people, one of you.
No.
I want you to know how many you guys my most crazy. Okay. Yeah. I'm not too much space for all my street.
It's a Bluetooth driver. The hell is it trying to do to use a Bluetooth driver? Fuck me. Sorry. My computer has stopped working. Sorry. Yeah.
A weird question.
Yeah.
From this react,
Yes.
so if there's this reaction
Uh-huh.
after we learn like
Yep.
for this reaction,
Yep.
does that mean there are equations that are with this reaction and sometimes are not?
I don't know what you mean.
Okay.
Oh, when you're talking about Bronsted Lowry as opposed to like Arrhenius?
So like after this reaction,
Uh-huh.
because after we learn this, does that mean this reaction is on every equation?
After base equation.
Or is it sometimes not this good on both
Sometimes it's
sides?
not. Sometimes it's not. Don't worry about that distinction too much at this point. Okay? Yeah.
Sorry for
Yeah.
the long explanation.
No, it's all good. It's all good. Yeah, no, I think it's okay. I think we should just be fine. Yeah.
Another weird question.
Yeah.
You know how all the equations are like the same?
Yeah.
Like zeros?
Yeah.
Would it be 100% impossible if there were equations with a line?
We just don't write questions that way. It's just not done in chemistry.
So is it like impossible?
It's not impossible. It's just, it would be weird. It would be like putting a period in the middle of your sentence or something. Do you know what I mean? It's just like not a normal way of doing things. So it would be like if you took like a normal sentence and you put the end at the beginning, it would just be hard to read. Yeah.
Not like 100% impossible.
Pardon me?
When you say it's not 100% not like impossible,
Well, it's not incorrect, but it's like writing a sentence that's grammatically wrong. Do you know what I mean? The grammar is wrong. The meaning is there, but you've written the grammar wrong. Yeah? Yeah.
I was like, just
Yeah.
and then like, what if there's something?
Yeah. No. No. Ugh.
You're ruining my tangent. Like